7.2, solving compound inequalities. Compound inequalities are literally two inequalities that are brought together with either an and or an or in between them. We're going to start with working with and, then move into or. But when you have an and statement, it means that both inequalities are true. An or statement means just that one of those two are true. So if we look at the first example, 1a, we have -3 is less than or equal to x minus 2, which is less than 4. Our whole idea with these is to get the x in the middle by itself. So you could do this one of two ways. You can form two inequalities, or you can work with just the one. If you work with just the one, like we're going to do with this one, we're going to take anything that's with the x inside the middle of the inequality sides and bring it to the other sides. So if we add the 2 to get it away from the x, we're going to add the 2 to the -3 as well as the 4. So that way we get that x by itself. So this is going to become -1 is less than or equal to x, which is less than 6. Now with these, you want to always make sure that your lowest number comes first with these inequalities. So the -1 is less than 6, so that comes first. Another way to solve these is to solve or to make two inequalities. So if we look at example B, 4 is less than or equal to x plus 2, which is less than 8. We would make 2, making 4 is less than or equal to x plus 2, and then x plus 2 is less than 8. And then we would solve both of these separately. So we would subtract the 2 from each side with the 4 is less than or equal to x plus 2 to get 2 is less than or equal to x. And then we would subtract the 2 from each side with the x plus 2 is less than 8 to get x is less than 6. We put this back together. Do we see if the x's are next to each other? Yes, they are. The 2 would go first. The 6 would go last because the lowest goes first, highest goes last. Our variable is x, so that goes in the middle. Between the 2 and the x, the sign is open to the x, so it stays open to the x. Between the x and the 6, it's open to the 6, so it will stay open to the 6. For C, we have -5 is less than or equal to 2x plus 3, which is less than 9. So again, we're going to move that 3 over by subtracting it from each side. So this is going to give us -8 is less than or equal to 2x, which is less than 6. From here, that 2 needs to be divided from each part to get just x in the middle. Our signs are not changing because we're not dividing by a negative. So this is going to be -4 is less than or equal to x, which is less than 3. Again, if you wanted to separate this into two separate inequalities, you could have done so as well. For D, we have -2 is less than x minus 3, which is less than 5. So we're going to move that 3 over and add it to each part. Oops. So we have 1 is less than x, which is less than 8. Our lower number comes first, so we're good. For E, we have -10 is less than 3x plus 2, which is less than or equal to 8. So we're going to move the 2 over first. We're going to get -12 is less than 3x, which is less than or equal to 6. Then we're going to divide every part by that 3 to get -4 is less than x, which is less than or equal to 2. Now, what I didn't realize from the very beginning is that we are supposed to be graphing these. So with this one, if we were to graph it, we would need a -4, we would need a 2. The -4 is going to have an open circle on it because the sign is not equal to, and the 2 will have a closed circle on it because it's also equal to. With an and statement, those lines will go towards each other, so they will connect both circles. For C, we would need a -4 and a 3. There would be a closed circle on -4 and an open on 3, and the line would go in between. For D, we would have a 1 and an 8, and then an open circle on the 1, an open circle on the 8, and the line would go in between. So there's different ways to write these lines, which I'm going to show you with all of these. So you see how there's one with a squiggle, there's one with a straight. As long as I can tell where the line is in between the two circles, you're okay. Another way to do this, for example A, you'd have a -1 and a 6. You have a closed circle on -1 and open on 6. You can go up a little bit and connect them that way. So that way the line's above the number line. So that's fine as well. And then for B, we have a 2, we have a 6, closed circle on 2, open on 6, so we just connect the two circles. For our next set of examples, we're dealing with OR statements. So with these, our lines are going to go opposite of each other when we graph them. So these we're going to be solving two separate inequalities for. If you look at A, we have 2w minus 1 is less than 3, or 3w is greater than or equal to w plus 10. Remember, we want the w's by itself. Typically, we want the w first because that'll tell us which way to draw our line. So if we look at the first inequality, 2w minus 1 is less than 3. We're going to add the 1 to both sides. We get 2w is less than 4. Then we divide each side by 2 and get w is less than 2. For the other inequality, we're going to subtract w from each side. We get 2w is greater than or equal to 10. Then we divide each side by the 2, and we get that w is less than or equal to 5. Now, look at the two inequalities. Does the inequality on the left include the smaller number? Yes. So when you draw your line, you're going to have a 2, you're going to have a 5. The 2 is going to have an open circle. The 5 is going to have a closed circle. Now, to tell which way you're drawing your lines, the w is less than 2. That means you're going to draw your line to the left. The sign points to the left. W is first. You're going to draw the line to the left. For the w is greater than or equal to 5, we're going to draw the line to the right because the w comes first in our inequality. The sign points to the right, so our line's going to run to the right. When you go to write your solution for this, you are going to have w is less than 2 or w is greater than or equal to 5. For B, we have -4 plus x is greater than 1, and -4 plus x is less than -3. So we're going to start by adding the 4 to both sides on the first. We get x is greater than 5, and then we add the 4 to the other inequality to get x is less than than 1. Now, look at the way these inequalities are. Which inequality includes the smaller number? The x is less than 1. So rewrite this as x is less than 1 or x is greater than 5. So this is going to be your compound inequality. And then for your number line, you're going to have a 1 and a 5. You're going to have an open circle on both of these, and your line is going to run opposite of each other. For C, we have 2x is less than or equal to 6. We're going to divide each side by the 2 to get x is less than or equal to 3. Or 3x is greater than 12. So we're going to divide the 3 on that one to get x is greater than 4. Look at your inequalities. Does the inequality that include the smaller number come first? Yes. So draw your number line. We're going to have a 3. We're going to have a 4. Closed circle on 3. Open circle on 4. Those signs point away from each other. So we're going to draw our line away from each other. And then our compound inequality for this one would be x is less than or equal to 3 or x is greater than 4. For D, we have x minus 5 is greater than or equal to -2 or x minus 5 is less than or equal to 6. So we are going to add the 5 to both sides for both of these to get x is greater than or equal to 3 or x is less than or equal to 11. So from here, we look at this. This here is an and statement now. Look at the way your inequalities are. The 3 is less than 11. That goes on the left. your signs point towards each other. So this is going to become a compound inequality of an and statement. So we're going to have 3, we have 11, we have our variable x. The sign is open to the x between the 3 and the x, so it stays open to the x. The sign is open to the 11 between the x and the 11, so it stays open to the 11. So this is going to be our compound inequality. And then with our number line, we're going to have a 3, we're going to have 11. Because these are compound inequalities and they are an and statement, that line is going to be in between the two circles, so they're going to connect the two. For E, we have 4x minus 1 is less than 15, or 8x is greater than or equal to 48. With the 4x minus 1 is less than 15, we're going to add the 1 to both sides to get 4x is less than 16. Then we divide by 4 to get x is less than 4. For the 8x is greater than or equal to 48, we divide each side by 8. We get that x is greater than or equal to 6. So now look at your inequalities. The one on the left includes the smaller number. So we're going to have a 4, we're going to have a 6. The sign for the 4, it points to the left, so our line's going to run to the left. That one's going to be a closed circle. The 6 is going to have a closed circle because it's also equal to, and that line goes to the right because the sign points to the right. With your compound inequality, this is an or statement since both of those lines go away from each other. So we're going to have x is less than 4, or x is greater than or equal to 6. For our next set of examples, we are writing compound inequalities from each graph. So if we look at example A, this -1 has a closed circle on it, so it's going to be equal to 1. The sign points to the left, so our inequality sign is going to point to the left, and we're just going to add an x in there. For this 7, it is closed, so again, it's going to be equal to. That sign points, or the line points to the right, so the sign's going to point to the right, and then we're just going to put the x in there. Now, because these two lines are facing opposite of each other, this is going to be an or statement, so when we write it, it's just going to be x is less than or equal to 1, or x is greater than or equal to 7. For B, we have a 0 and a 6. The 0 is equal to, and then that sign points, or the line points to the right, so our sign's going to point to the right. Put the x in there. For the 6, that's open, so it's not going to be equal to. Our sign, or our line points to the left there, so our sign's going to point to the left. Add the x in. Because these two lines connect, this is an and statement. You cannot write it like that. You have to write the compound inequality. So remember, smaller number, variable, larger number. Between the x and the 0, the sign is open to the x, so keep it open to the x. Between the x and the 6, it's open to the 6, so keep it open to the 6. So we have 0 is less than or equal to x, which is less than 6. For C, we have another compound inequality that's an and statement because the two lines connect. So we have a -8 and a -3. Our variable is going to be x. Now look at the way this is. We have that the number is greater than 8, but less than -3. So if a number is greater than 8, x is greater than 8. If the number is less than -3, the x is going to be less than -3. So you can do it this way as well. Totally up to you. For D, we have a -4 with an open circle, and the line points to the left, so our sign's going to point to the left. Just add the x in. We have a 2 with a closed circle, so it's going to be equal to. Our sign points to the right, so our line points to the right, so our sign also points to the right. Add the x in there. These go opposite of each other, so just put the or in between them. So x is less than 4, or x is greater than or equal to 2. For E, we have a -2 and a +2. The -2 has the closed circle, so it's going to be equal to. The 2 has the open circle. Now, the -2, the line is running to the left, so our sign's going to point to the left. Add the x in there. With the 2, our sign points to the right, so our because our line points to the right, and then add the x in there. These two go opposite of each other, so put the or in between them. Your next part of your lesson deals with writing a compound inequality to represent the word problem that you have here. So with example A, we have the recommended pH level for swimming pool water is between 7.2 and 9.6 inclusive. Inclusive just means that it includes those numbers. So when we write this, we're going to have a 7.2, we're going to have a 7.6. It's between these two. So our inequality is going to be a compound inequality of and. So the reason why the sign gets open to the x between the 7.2 and the x is because the quantity is greater than or equal to the 7.2. Same thing with the quantity for the 7.6 is either less than or equal to the 7.6. So if we go to graph these, we're going to do a 7.2, we're going to do a 7.6. Those lines are going to be in towards each other with closed circles because they include those numbers. For our next example, it says the recommended free chlorine level for swimming pools or swimming pool water is between 1.0 and 3.0 parts per million inclusive. So again, it includes that. So we're going to have a 1.0, we're going to have a 3.0. Our variable is x. It's between these two, so it's going to be greater than or equal to 1, but less than or equal to the 3. So on our graph, we're going to have a 1.0, we're going to have a 3.0, and the lines are going to go into each other with closed circles. For C, it says the recommended alkalinity level for swimming pool water is between 80 and 120 parts per million, inclusive. So again, it includes the 80 and the 120. So if it's between these, x is going to be greater than or equal to 80, and x is going to be less than or equal to 120. So again, on our number line, we're going to have the 80, we're going to have the 120, close circle on the 80, close circle on the 120, and then it goes in towards each other.